Okay, I'll let you carry on with this in just a second, but just to kind of consolidate what we've done so far, okay, I've asked you to all plot y equals x squared because you've got that reference graph on there, okay? Has anybody tried timesing this by some number? So has anybody tried, for example, doing 2x squared, or 3x squared, or 4x squared? What do you notice? What do you notice? Yeah, it's getting skinnier, right? So how could you describe that? So if this is the original graph, I'll do this in green. Okay, this is my original graph. You're saying by putting a 2 in front of that x squared, so this is y equals x squared. By putting a 2 in front of that x squared, you're basically making it skinnier. So how would you describe that? How would you describe what's happened? Describe what's happened here. Other than making it skinnier. Because you're right, I kind of get what you're saying there, but can anybody describe what's happened to this graph to get to this graph? Gradient's getting steeper. Good. Would you be happy this is a stretch? It's been stretched. Imagine somebody's grabbed hold of that and literally yanked it upwards. Yeah, so it's been stretched in that direction. Now it's been stretched in which direction? X or Y? In the Y direction, yeah? How much has it been stretched by? How much has somebody grabbed hold of it and pulled it upwards by? It's 2, right? So somebody's grabbed hold of this and basically stretched it up so it's now twice as steep as what it was before. Is that okay? Yeah? So it's a stretch in the Y direction by a scale factor. Okay, so by a scale factor of 2. Okay, and you can see that from this. Okay, so somebody's grabbed hold of this and literally stretched it up that way so it's twice as steep as it was before. Okay? Okay, now has anybody tried, what if we try adding some things to this? So for example, let's try y equals x squared plus 5. Okay, so this is my original graph. Do it in green, y equals x squared, my plain vanilla y equals x squared graph. Does anybody notice what's happening if you add or subtract a number to it? Talk to me about what's happening here. Exactly, so it's being moved up or down by whatever's being dictated here. This is similar to what the y-intercept was doing on our y equals mx plus c, right? If you change this number at the end, you change what you're adding, you're literally just moving the graph up or down. Okay, so in this case, it will be, what's a better word than moving? Begins with a T. Translate. Yeah, it's close. Yeah, so you're translating. I mean, think about it, right? If you translate from one language to another, you're literally saying the same thing, but you're just moving it from one position to another, one language to another, right? So you're translating in the y direction, so up or down. In this case, by 5 units. So going up by 5 units. Is that okay? Good, excellent. Now, nobody yet has managed to, or they might not have done, Agnes, you have, you might not have yet broken that line of symmetry, okay? So I just want you to have a little play around for maybe 5 minutes, see if you can think about adapting these things to see what happens if you can move it left or right.